The first of the essential characteristics that I want to cover is on-demand self-service.
This video is brought to you by EpiPies Academy.
The definition from the NIST is a consumer can unilaterally provision computing capabilities such as server time and network storage as needed automatically without requiring human interaction with each service provider. The easiest way to describe this is to show you how it actually works. So let's have a look at Amazon Web Services, and I will automatically provision a virtual machine running in the AWS cloud. So I'm here on the AWS console page, and I'm going to sign in with my account. And then I'm going to click on the services button up in the top left and choose the EC2 service. That stands for Elastic Cloud Computing, and this is Amazon's service where I can provision virtual machines. So I'm going to fire up a new virtual machine instance. So I'll click on the Instances tab over on the left, and then click on the Launch Instance button. So this is going to take me through a wizard where I can configure all the settings for my virtual machine. Now with AWS, you can actually sign up for a year's worth of free service. It only allows you to provision the lower end servers, but it's still a really good way to find out about cloud computing by practicing it yourself. So that's what I'm doing here. I've signed up for a year's worth of free service. On the first page for my virtual machine, it asks me what operating system I want to install on there. I'm going to choose Windows Server 2016 base, which I can see is included in the free tier. I'm not going to have to pay for this virtual machine. So I select that, and then on the next page, it's going to ask me how powerful I want this virtual machine to be in terms of how many virtual CPUs it's going to have and how much memory it's going to have as well. Again, I'm going to choose the free option here, which gives me one virtual CPU and 1 gig of memory. Then I click on Next to configure the instance details. In here, it asks me how many instances that I want to configure. So this is very useful. If I wanted to spin up 5 new servers at the same time with the same settings, I could put 5 in here and it would let me do it in one go. I only want one of them. I also specify how I want the networking to be configured as well. I could set up different network settings ahead of time where I can have different subnets, and then when I create my virtual machines, I can put different virtual machines in different subnets, and that's going to control the connectivity between them. Again, I'm happy with just using the default subnet in here. Another option down at the bottom is the tenancy. I can choose either shared or dedicated. Shared means that this virtual machine is going to be running on underlying physical server hardware that can be shared with other customers. So I'm customer A, customer B could also have virtual machines running on the same physical server underneath that. If I chose dedicated, I'm guaranteed that it's only my virtual machines that are on this physical server. I'd maybe do that if I had to for compliance reasons, but that's obviously going to be a more expensive option. So I'll just choose shared in here, and then I'll click on Next for add storage. In here, it's going to default to giving me a 30 gig disk for my boot disk. I'm happy with that. I've also got options if I choose other types of storage about the kind of performance I'm going to get for the storage too. Again, I'm just going to take the default here. I click on Next, and it's going to take me to the tags page. This is for if you've got a lot of virtual machines, you can put different tags on your different virtual machines to organize them, and you can search for those later. I've just got one virtual machine, so tags aren't really relevant for me. Click on Next for the security group, and this is where I can configure the firewall rules. This is a Windows server. I'm going to need to be able to manage it. So by default, remote desktop is allowed to come in. If I was going to run a web server on here, for example, I would also add another rule in here to allow incoming web connections on TCP port 80. I don't need to do that for our example, so again, I'm just going to accept the defaults here. I then click on review and launch. It's going to give me a summary page that shows me all of the different settings, and then I can click on launch, and okay, the next page, it's going to prompt me to create a key pair if I don't have one already. I've got one already, but let's make a new one. So I'll create a new key pair and I'll give it a name. Let's just call this demo, and then download the key pair. What this is for when I initially connect to it the first time for management purposes, I'm going to need to use this security key. I'll show you how this works in a later lesson when we actually connect into this virtual machine. So I'll save the file. It's going to save it into my downloads folder. Now with AWS, it's really important, do not lose that file because you can't get it back again. Then I click on launch instances, and it's going to create the virtual machine for me. So what it's doing in the background is it's configuring a virtual machine with all of those settings. So on the server side, the compute side, it's creating a virtual machine with the amount of vCPUs and the amount of memory that I selected it. It's also going to install the Windows operating system in there for me. It's going to install that on a 30 gig boot drive because that's what I selected for the storage, and it's going to configure my firewall rules as well. If you think about how this would work in a traditional deployment, you would have to physically get the server racked up, and then this would go to different IT teams to configure all of those different settings. To actually rack up the server, install the operating system, do the patching on there, and install any applications, that would be done by the server team. Then to configure the networking settings, so the subnet that this virtual machine is going to be in, and also the firewall rules to allow the incoming RDP connection, that would be configured by the networking team. And then for the storage for this virtual machine, that 30 gig boot disk, that would have to be provisioned by the server team and attached to this particular server. So that would all take a lot of time, and it would all be done as individual manual tasks by the different teams. You see, when I do it in a cloud environment, I just use a really convenient web front end, and everything is done for me automatically in the background. This doesn't raise a ticket and then send it to somebody to do this manually. Behind this web-based front end, there's automation software at the back end, which is talking to my server systems, to my networking systems, and my storage systems, and is configuring everything automatically for me. So the benefits I get from this is this server is going to be up and running in less than 15-minute time. And because it's all done automatically, it's much easier for my IT staff. I didn't need to have members of my IT department running around doing all of these time-consuming jobs. So that's how we spin up a virtual machine on AWS. Let's go back to the slides to wrap up this lesson. Okay, so you saw that we can have a virtual server or pretty much any other software service up and running in the cloud very quickly, usually in less than 15 minutes. Let's compare that with our traditional on-premises and colo deployment models. So in most traditional deployment models, it's usually going to take at least a week to get a server up and running. The purchase needs to be approved and the server ordered. It then needs to be delivered. It needs to be physically racked up and cabled. The server team need to install and configure the operating system, patches, any standard software, and the applications for that server. The networking team need to configure switches, routers, and firewalls. The storage team need to configure the storage system and SAN switches. So that all takes a long time, often several weeks. Now, the lead time to get it up and running will be quicker if you're provisioning a virtual machine rather than a traditional bare metal server, but it still takes time for the different teams to manually complete their tasks. So on-demand self-service is a big advantage of cloud computing. It lets us get our servers and our services deployed much more quickly than we could with the traditional models.